I will start with why. Why would you use a drone for bathymetry? And there are several good reasons or scenarios in which you would do that. Hello. Okay. Drones are especially useful for bathymetry in very shallow or small bodies of water, where the bigger craft cannot be used, like especially equipped boats or submarines. And also they can be very expensive and hard to use in many situations. So this isn't a presentation about how everybody should switch to drones now, but to show you that drones are a good tool to have in your toolbox, and that there are situations when they can come in handy in bathymetric surveys. So the second reason why you would use a drone is in hard to reach locations which have no points of entry. So you cannot deploy a boat or unmanned underwater vehicle, like in small lakes, some coastal areas, floodplains, or especially marshes. The third situation would be where you have seaweed or debris in the water. That would make it hard for floating things to move around. Or there would be like steep banks or something, other things like that. Also, you could use a drone in contaminated water or in other dangerous conditions and other liquids, not necessarily water. And when you have stronger currents, that would make other craft struggle, especially in those small bodies of water, smaller rivers. And drones have their advantages, like fast setup and easy deployment, good repeatability of missions, where you can create one mission today and repeat it tomorrow or the week after or next month or next year. And they have excellent maneuverability, so you can use them in tight spaces. Now, the second slide will be about why you wouldn't choose to use a drone. So drones are more sensitive to adverse weather conditions like rain, snow, or heavy winds and low temperatures than maybe other types of craft. Also, drones aren't very well suited for large areas, especially very large areas, where you would need maybe hundreds of battery changes to accomplish a mission. You would maybe be better using a boat there and just going until you're finished. Also, the speed is limited because you have a payload that is hanging from the drone. You cannot go very fast or the payload will tilt it. And then survey accuracy would suffer. We will show you how to mitigate this with special survey techniques, but this will present some other limitations. Also, care must be taken not to snag the echo sounder cable in obstacles in the water or at the surface, or not to run into overhanging tree branches or other obstacles. Also, drone-carried echo sounders aren't suitable for extreme currents. In these situations, we are suggesting you to use a ground-penetrating radar and not to put anything in water at all. Okay, so our system consists of a UAV, a drone. We have attached a radar altimeter to it to see the distance to the ground or water. Underneath, we have mounted the SkyHub onboard computer. More about that later. And it is dragging an echo sounder behind it. So what is this SkyHub? So the SkyHub is the onboard computer that we use to enable drones to do certain types of specialized missions and collect data from payloads like the Echo Sounder. Its functions are, it is used to implement terrain following functionality in DJI Enterprise drones like M210 and M600. It gathers data from external payloads like echo sounders, magnetometers, ground penetrating radars, gas and radiation sensors, or metal detectors. It also fuses this data with information from the autopilot, like your GPS location, and data from the altimeter, like the real altitude over terrain. Also, various sensors output data in various formats. So SkyHub translates these formats so that the resulting files can be used as processing software directly. And SkyHub implements custom flight control algorithms that are not natively available on the drone. These data collection, fusion, and conversion functions can also be used with Pixhawk and Ardocopter firmware. So next we proceed to these custom flight control algorithms that will be very useful for bathymetry. The first one is true turn following mode, which is available on DJI 3 or M600, M600 Pro drones, or M210 and M210 version 2, and also M210 RTK drones. Also, we have grasshopper mode that is currently available on DJI 3, M600 and M600 Pro drones, and M210 and M300 support is coming soon. Also, one thing we are working on is an altitude hold mode that is coming soon, and also support for M300. Next, I will tell you more about these various flight control algorithms. So in true terrain following, you have a drone that is keeping altitude relative to ground or to a body of water instead of relying on the barometer of the drone, and collecting data all through the mission. The second mode we have is the grasshopper, in which we can move from point to point and lower the probe in these points to get readings. This is good, as we talked before, that drones can be used where there are some obstacles in the water, that you don't drag your echo sounder behind yourself, that you just dip it into water in some points, just so that you don't drag something and the drone doesn't crash. And the third, altitude hold mode, is useful when you have very tight spaces or river banks or somewhere where planning an automated mission is, if not impossible, then at least very challenging. And this mode would allow you to keep an altitude according to the altimeter and just use the drone to move around, keeping this altitude and collecting your data. So some comparison of these modes. So with true terrain following, you would get low speed flying and get continuous profiles. Low speed, like half a meter per second or a meter per second, is necessary to keep the echo sounder level so that it doesn't tilt and doesn't skew your readings. Second, high-speed sparse points of measurement can be used with grasshopper, where you can move quickly from point to point and measure data in these specific points. A third situation where you are flying around obstacles, there you could use the altitude hold mode to hold altitude and navigate the drone manually. Also, this would be useful when navigating around the coastline. You can use all these three methods in shallow water. This true terrain following maybe not in completely shallow water because it will drag the sensor on the bottom. But 15, 20 centimeters, maybe 30 centimeters of water will be enough. When seaweeds and other obstacles are near the surface, you would use the grasshopper mode. And for mission repeatability, you would use true turn following a grasshopper mode, because altitude hold mode, when you are moving around manually, isn't really repeatable. And in stronger currents, you would use grasshopper mode so that your sensor isn't always tilted. This grasshopper mode would dip the sensor in water, and when it is dipped, instantly you get a reading, and then this sensor is taken by the current. Okay, we are currently offering two echo sounders. One is the ECT 400 single frequency scanner, and the other is ECT D032 dual frequency scanner. The effective measurement range for the ECT 400 is from 15 centimeters to 100 meters. And for the dual frequency echo sounder, it is from 0.5 meter to 200 meters. Measurement precision is, I think, very good, but you should check probably the exact specifications of these sensors. They also have very good temperature range and weight that is suitable to be carried on a drone. Data rates, we'll be talking about this a bit in a moment. But just quickly, I will tell you, in the depth mode, where you only get one depth reading per measurement, you can have higher data rate. And in echogram mode, where you have to wait for the entire signal to go there and back again and record it, there is a smaller rate accordingly. So these two modes give you different data. This NMEA mode that gives you depth data, this gives you an NMEA file that you can use in your software. And echo sounder mode gives you the echogram. Also, SkyHub records a position log, which has all the data about the depth, about the altitude from the altimeter and GPS coordinates, as well as the sensor angles and water temperature that you can use for your own processing, or to filter something out, or to use in some software that doesn't support these previous files. Next, we will move to how we would do this in UgCS. There are two ways to do a bathymetric mission. You can use manual points or make a photogrammetry mission and adapt it to use by echo sounder. For this, it is nice to have an echo sounder as a camera payload so that you have can place points and make the mission easier. And the mission itself, as I will show you in the next slide, you will set this camera for the mission. You will set the forward and side overlap to 50%. And you will set the mode that adds additional waypoints. I will now show you how this works in UgCS. Okay, we now have UgCS open, and also the UgCS custom payload monitor that we'll be using to manage these modes. We have a drone here near to our body of water. We will be creating a new route. Let's call it survey. We'll choose the drone we use. We will set some mission limits, like maximum altitude and return to home altitude. And then we will plan the mission. So bathymetry missions will need a first and last waypoint that don't have any actions. so that the drone doesn't lower in these places where you are already on the ground. So we'll be setting the first waypoint near where the drone is. Maybe setting altitude to 10 meters, no reason to go to 20. And then we'll make a photogrammetry. We have chosen the echo sounder sensor I have created previously. We'll be using this ground resolution to set the distance between measurement points. So in this case, to 15 meters. And we have set the setting that we want to have additional waypoints. So let's create the mission. Set our line direction to go along the longest line. And we already have waypoints spaced 15 meters from each other that we can use for the mission. At the moment, you need to convert this mission for use with bathymetry and the custom payload monitor. So we will do this right away. I now set the I'll set the last waypoint also and convert the mission to be used for bathymetry. I will choose parameters, route to waypoints, and hide the original survey. This has now created a mission where we have individual waypoints that can be moved or deleted as we wish. We can check that there are no waypoints on the ground and delete those. And when we are satisfied with everything, we can select everything using Ctrl-A, set the altitude, which will be a bit higher than our cable length for the altimeter. Let's say 5 meters in this case, so that you can see how it lowers. We'll clear all existing actions and set the camera mode to single shot mode. We will now clear these actions on first and last waypoint. Again, clear all actions on the last waypoint. Clear all actions on the first waypoint as well. You can move between waypoints like this as well. And now our mission is ready. So next thing to do when we are at the location is to upload the mission to the drone. The mission will be uploading. You might notice that in the CPM, I already have an altimeter reading and echo sounder reading. The echo sounder is, maybe if you see my camera, it's just here in the barrel, so that we have some nice data to work with. So the mission will be uploaded shortly. Route uploaded. Okay, we have a message that the route has been successfully uploaded. And now we can enable the grasshopper mode. We will read the settings from the grasshopper. See if our target altitude is correct. This should be a little less than your cable length. We will set the descent speed to 1 meter per second and hover time in our points to 2 seconds so that we have enough time to gather a few readings. Next, we will click Configure button. We will get a message that Grasshopper is enabled. And now we can put the drone into auto mode and go on our mission. The drone will lift off to our set 5 meters altitude. We will go to the first waypoint and lower our drone there. Yes, the drone goes down to depot our echo sounder in water. So on to the next waypoint. And so on. When the mission is finished, the drone will return in our home location, or thereabouts. We can also move it back and land it manually. Also, if we don't want to continue the mission, or we see some obstacle or something, like a low-flying helicopter, we can take manual control and take the drone back just by flipping the switch on the remote. We have stopped the automatic mission, and we can take the drone back. I think I won't continue this mission. I will just show the other way of doing these bathymetry missions that will use just a normal terrain following mode. Okay, my drone is landed now. I will make another mission, and that will be normal terrain following mission. So I will hide this mission. Terrain following will create new route, terrain following. Again, choose drone and set parameters. And terrain following just requires some area scan to be able to run. So we click the area scan. We place the area scan on our survey. But as we will be dragging around these points, dragging around the echo sounder in terrain following mode, we have to keep really clear of all the banks and any obstacles that might be in the water. We will be able to move around these obstacles, going to manual mode and back, but it's better to plan the mission safe. Also take into account that normal GPS has some up to 3 meters of error, so you can use the distance measurement tool to see if your points are close to the banks or if they're okay. Okay, it seems like we have picked quite a big lake. Let's see what happens here. Okay, we have sight distance set 1 meter. For this demonstration, I should probably set 15 or maybe even 20 meters sight distance. I will set also flight height to my cable length, minus some 20 centimeters to actually dip the sensor in the water. So, but I will be doing that in the CPM. So here I can set just some kind of safe height, safe altitude. We can use the same 5 meters we used before. Again, let's arrange the mission so that our longest, so the lines are this longest side. Seems to me we could even take maybe 15 meters sight distance. Okay. Let's see how this recalculates. Okay, well, here it seems that we will be moving onto the ground. But again, this map isn't that precise. You should always check. And the best way to check is when you power up your drone in the field, you will see where it is on this map, and you will know if you need to move this mission you have relatively to how the drone appears in real life in comparison to what is displayed here. So to move your mission or to rotate it, you will use this blue thing. To move it, there's a plus sign underneath the arrow. You can move the mission around. To rotate it, you just grab the circle. And the mission looks okay now. We have set 5 meters. We can close this grasshopper widget here and add the terrain following, which we'll be using for this mission. The mission is ready to be uploaded. We can upload it, start truth from the beginning. And the mission uploaded. You will notice that I didn't put any start on or end waypoints here, because at least on M600, these TTF missions can be started from the remote, which I find very handy. I'll show you how I do it. Here in the terrain following, we will read the settings from the SkyHub. We see that our target altitude is 2.45 meters here. So that is probably okay if our cable length of the echo sounder is 2.7 meters. We'll be dipping it in. We will set the safe altitude to, let's say, 2 meters, because this altitude gets added if you get an altimeter error or something. To your current height, these 2 meters will be added so that you don't fall down on the ground. And the speed I will set to 0.5 meters or maybe 1 meter, so maybe you can finish to 1 meter per second, so maybe we can finish this mission here. Next, we click configure. And the terrain following is configured now. Sometimes it doesn't display the message. We can click the configure again. Nothing bad from that, but our activate button is already activated, so we can start this mission. So the way I would do it, I would take a remote. I would start the drone up, lift it off from the ground, slowly taking care that I don't damage my echo sounder. Then I would move over the water. So that when the terrain following mission starts, my echo sounder isn't dragged on the ground. And I would move into F mode on the remote. I click into F mode, and we are now moving to the first waypoint of our mission. We are going down to the set altitude here, 2.45 meters. And here you can see when we are looking at the mission, that the mission lines are here up at 5 meters, but we are going lower down at this 2.4, 2.45 meters. In real life, altimeter would be used for that. Now I'm just using the simulator from the autopilot. So let's wait for this mission to finish. Oh, it's going across the lake to the first waypoint. One problem with not putting the first waypoint is that sometimes the first waypoint ends up on the opposite side from you. But especially on the water, this might be maybe the best way to do this, because as you move along your mission, your battery gets lower and lower. So if your battery goes to some 30% here at the end of the mission, you will still have a very long way to travel over water to your home location. So maybe it really is more prudent to go to the end first and finish the mission close to home to have better peace of mind. Okay. Once the drone is lifted up and we have SkyHub connected to the drone, data recording starts. And that is happening also even if you don't start the terrain following mission or the grasshopper mission. So you can get creative, maybe even use it manually, even without the altitude hold mode, especially if you have a spotter who can check these altimeter values and echo sounder values and tell you what you should be seeing, and you can keep your eyes on the drone at all times. Okay, almost half the mission done now. I think there is no point in continuing it. I will just land the drone and move on with my presentation, okay? Again, going out of the terrain following is easy. You go back to P mode. The drone goes out of the automatic mission, and you can move it back to your home location. Maybe not at this altitude. I will climb some more. So I am now at 4.4 meters. That should be okay for my echo sounder. And now I can land slowly and gently. Sometimes it helps to land the echo sounder itself and then move the drone a bit forward so that you don't sit directly on it. Okay. This concludes the practical presentation of the two ways you can currently manage your bathymetry missions with UgCS and the custom payload monitor. I will switch back to my presentation again and see what we have left. So we have some frequently asked questions, and three of those are, what is the positioning lag when dragging the echo sounder with the drone? Because when you see any of our videos or pictures or something, you can already see in them that the echo sounder is slightly behind the drone. So in our experience, when you're using almost 3 meters of cable, around 2.7 meters, at 0.5 meters per second speed, the lag is around 20-30 centimeters, and 1 meters per second it is around 50 centimeters. You could reduce this lag by shortening the cable, obviously. That would mean you would fly closer to the surface of the water, have less time for reaction, but that would reduce this positioning lag. The second question is, can RTK be used for more precise positioning? And the answer is yes. In case of the M210 RTK, the SkyHub records the RTK coordinates from the autopilot. And if you are using an aftermarket RTK solution like with Reach, you can substitute coordinates in the resulting data when processing it in HydroMagic. And the third one is what liquids can surveys be performed in. Obviously, if you're not rowing across the surface of this liquid, it can be anything. It can be water, oils, really, your imagination can run wild. And you will only need to clean the echo sounder itself in the end. But you have to choose the correct speed of sound in this liquid afterwards when processing to get correct data about this. And there are some tools available that can provide these sound and velocity depth profiles that you can use in HydroMagic. And one such solution is provided by our partner Stern Group. Here is their solution. So instead of dipping it here from near the coast, you can also mount it on the drone and do a full speed depth profile for the place you're in, practically regardless of what liquid you're exploring. So there are some downsides of manual dips, like not deep enough, does not test for changes in profile across lake, and requires access to lakeside. And if we use this sound velocity and pressure sensor connected to the Sky Hub, we can get the data from the middle of the lake or water, what have you, to get a correct representation of what the sound, the speed of sound is in this medium to be used in post-processing. Okay, this is it for my presentation today. I will be passing the flag on to Alexei. Alexei, are you ready?
Yes, but Chris, could you show your setup? There is a question to demonstrate drone, what you use for demonstration, and your special test bed for Echo Sounder.
Okay, I hope you will see it. Quite tight quarters here.
So you can double click on the Chris video, see it full screen.
Do you see it? So this is my workspace. Here we have the barrel of, this time it's water. We have the echo sounder suspended in the barrel to give us some readings. We also have the radar altimeter here on the side of the barrel so that I can do some altimeter magic so that it doesn't go to sleep. And next to the barrel, we have the actual drone. So this is very tight. We are a very cozy little family here with the drone. Okay.
So it's off-the-shelf DJI M600, correct?
M600 Pro, yes.
Yes.
Okay.
Okay, so I will share my screen.
Yes, please do that.
Okay. Hello. I will demonstrate how to process data collected by our system. And after that, we will have Q&A session. We will discuss, we will answer your questions, and also, of course, discuss business side of our solution. So Sabine, could you help me? I cannot turn on my video. I still see Chris.
You see Christian, is just a second.
Ah, okay, I started video. So
yes.
I found magic button. So Chris, could you stop your video stream? Nice.
I have stopped him, so.
Okay, so I hope that my desktop is visible. And let's start. So our system can record files of 3 types. Basic type, it is Sky Hub log. You already saw it in presentation, but I will demonstrate it again. So here we have precise time till the milliseconds. We have drone attitude and coordinates information here. We have altitude measured by barometric altimeter and altitude measured by radar altimeter installed on the drone. Also, we have here information related to sensor connected to Sky Hub. In our case, it is Echo Sounder. So when sensor is not in the water, sensor Echo Sounder measurements will be 0, of course, because Echo Sounder works only if it is submerged to the water. At some point, a sounder was in the water, and SkyHub starts to log the data from a sounder. SkyHub logs not only depth, but it also calculates true depth using length of the rope specified in configuration of the system and current measurements of the radar altimeter. Also, we log temperature and pitch roll angles and yaw angle of the sensor. Using pitch roll data, we can filter out values, measurements, when sensor position is far from vertical. So, how you can use that file? You can use that file for some kind of custom data processing. Second type of file, it's standard NMEA file, which is absolutely standard for all echo sounders or bathymetric equipment. Here we have sentences for depth and depth below transducer, coordinate, and time information. What is the difference between depth below transducer and just a depth? Depth is also recalculated in the same way as we calculated through depth in our CSV file. So when you process NMEA file, you need to use depth, just a depth, not depth below transducer. And third type of files, it is full echo sounder data. It allows to see approximately the same picture as you can see on fish finder screens. Funny, but the same format of files is used for many geophysical sensors, and we can open the same file using software for georadars. And here we can see reflection from the bottom, second reflection. It is a result of ping pong of sound wave between bottom and surface. And also sometimes we can see something in the water. But of course, GPR processing software is not a right tool to process echo sounder data, and I will demonstrate you a right way of echo sounder data processing. We recommend, in general, you can use any software which can import and process NMEA files, because NMEA files are industry standard. We partnered with E4 software company, and we recommend to use HydroMagic software because it is pretty simple to use and fully tested with our technology. So let's go through processing step by step. First, we need to create new project. I will specify folder and name of project demo. And here we need to specify map projection. All our data is in UgCS 84. I recommend to write project description because in a couple of weeks, no one will remember conditions of survey. Next step is to import data downloaded from SkyHub. We will import NMEA files, select folder, and click NMEA. Okay, and here we should select a depth sentence. Okay, our files are imported. And here we can see a track of surveys, track of our survey, and each individual measurement point. So that survey takes 3 flights. So we have 3 separate flights, 3 separate data files, but we can process they all together. Next step. There is a difference in hydromagic between raw data and soundings. Soundings, it is what will be, it is kind of processed raw data. So I will generate soundings from raw data files. From original files, all three raw data files are selected. We don't have tide correction data, so we don't use. If we have sound velocity correction file, which can be gathered using a sound velocity probe. Now, for that survey, we don't have such data, but it is possible in hydromagic. And the last steps. We can filter data. We can manually edit echogram. It is very useful function. At least you need to take a look to your data profile. And if you will see spikes like here, most probably it's a false readings of the sensor. So here we can manually eliminate them. Okay, all 3 files are checked. And we can apply RTK corrections, PPK or RTK corrections on the one mask screen. If you use, for example, MLIT-rich PPK or RTK receiver, you can use a position solution file to correct, to inject precise coordinates inside of echo sounder data. So next, finish. We will get a processing report, and our raw data is replaced by processed data. Next step is to make our data colorful. I will create a new color gem. And I will auto-generate palette. So what is necessary to do that? We should remember maximum depth. We can check maximum depth here. It is approximately 5 meters for that survey. So I will specify from 0 to 5 auto-generation of color palette using a step of 1/4 meter. Okay, now we have colored data. Next step, we can import data. We can import map. We can download map from internet. I will use Google Map, and to position, to download a right piece of globe from internet, we will calculate boundaries of we will take coordinates using our data files. Okay, and now we have background map. We can rotate map, and of course zoom in, zoom out. Next step. Next step, I want to generate a matrix and 3D model of our lake. But for that, we need to draw a line, draw a coastline of our lake with 0 depth. For that, I need to create new boundary. And here, very important, we will use elevation of this boundary in matrix generation using zero elevation. Okay. So now we can generate matrix. Here, we need to select our sounding data. We will use all 3 processed files. We need to select boundary. We will use, our echo sounder has single channel, high frequency, and matrix spacing. 1 meter for small ponds or lakes will be quite reasonable value. And here we need to specify name of matrix file. Okay, and now we have a matrix, colored matrix, and here we can see calculated depth with 1 meter step, with steps specified for the matrix. Next, we can see our matrix as 3D model of our lake. And also we can export this model as a DXF file. Also, most standard way to prepare a report, we can generate contours. Output format can be DXF or 2 more formats. Again, select output. Select name for our file, and we will use the same color palette. Okay, and now we have a contour lines. And what we can do more, we can do a lot of calculations using collected data. absolutely standard is volume calculation, and we can, if we will do repeatable surveys, we can compare difference in volume between different surveys. For that lake, we have only one completed survey, but here we can select second matrix, and in that case, we can see difference in volume and area. It is pretty standard task for bathymetry to control level or volume of the liquid or water in pond. And the same function can be used to monitor amount of collected sediments in pond. It is also absolutely standard request to check, to monitor amount of collected sediments, for example, in oxidation ponds. So, many types of sediments cannot be penetrated by echo sounder, but if you will use repeatable survey and comparison function of hydromagic, you can calculate difference in sediments amount and dynamic of sediments amount. So that's all. That's all. Data processing for echo sounder, usually it's pretty simple. I will show you what we will have, what we can have in case of if we will use not anemia but full echo sounder data. I will import again raw data, but will use segway files. We will see more or less the same, but there is big difference in what we have in data. If in anemia mode we have just measured depth, here we can see more data. It's a full reflections, full recording of reflections of sound waves from underwater. It can be used, for example, to estimate, to directly estimate thickness of organic sediments. Non-organic sediments are usually cannot be penetrated by sound wave, but organic sediments, thickness of organic sediments can be measured or estimated by using double frequency echo sounder. Okay, that's all, and we can go to Q&A session. Okay. We have 12 questions at the moment. Part of them, part of questions are already answered. And let's start. What would be benefits of drone bathymetry comparing with standard way of doing that using boats? If you already have a boat with echo sounder and autopilot and you are happy with them, you don't need to switch to UAV. But sometimes you will not be able to use a boat. For example, if you cannot deploy it if access to the water is dangerous or restricted. It can be many cases. It can be a natural, for example, lake in the crater of volcano with very dangerous access to it. Or it can be some artificial pond with liquid which is not the water, which can be dangerous. So in some cases, water is water, but access to the lake or pond is also limited by some reason. First of all, safety reasons. Second reason, first reason, if you cannot use a boat at all. Second reason is when, for example, water is full of seaweeds or something in the water. Funny, but first idea of try to do bathymetry from UAV came to my brain when I saw rescue operation of standard remotely operated boat, which was stuck in seaweeds in the middle of the pond. Funny, but to recover boat, guys used M600 drone to deliver a rope with ring to catch the stuck boat. Also, next possible option: you don't have a boat, you have a drone and want to start new to provide new types of surveys for your customers. As I know, average prices, but for high quality boat with autopilot and survey grade echo sounder, price will start from approximately $25,000–30,000. If you already have a boat, drone, your initial investments will be at least 3 times less. So, I think it's the main reasons. Yeah, main reasons. Next question: why to use risk drone when we can use small boat? Of course, use a boat. If you have a boat, please use it. But when we fly over water with expensive equipment, we always order insurance. Insurance for the set of M600 drone plus echo sounder plus everything costs approximately €10 per day. It is nothing. But so my 2 recommendations: if you already have boat and can use boat, please use boat. If you will use drone, please order insurance. That's all. Can the system work in areas with waves? What is approximate wave height? Answer is we don't know yet. In case of big waves, in general, we don't recommend to use drone with anything on the rope under drone. It can be not only echo sounder, it can be sensors like what we have in background. Video. Okay. It can be magnetometer, it can be metal detector, many sensors. We don't recommend to use such setups if wind is stronger than 3 to 5 meters per second. In such wind, waves will not be very high. Another consideration that radar altimeter, which we use, averages measured altitude in the quite big footprint. In case of altitude approximately 2.5 meters, its footprint will be approximately half of meter in diameter. It will be ellipse, but roughly half of meter in diameter. So altitude measurements above waves will be averaged. Yeah, and we are waiting for more or less good weather to do test surveys near coastline in Baltic, near Riga. So maybe next week we will have test data. What kind of clients could be interested by a bathymetry survey service? It is, as I understand, that question related not to our solution, but in common for about bathymetry. So many types of customers. It's before any construction works in lakes and sea. If you will build a bridge, if you will lay pipe or cable, you need to know depth profile. For scientific purposes, to predict flooding, to monitor amount of sediments in artificial or national ponds or lakes. So there are a lot of applications for bathymetry, and it is huge business around the world. If we will speak about our solution, it is not replacement for standard methods of bathymetric surveys using remotely operated boats or automated boats or manned boats or ships, of course. But we see together with current and potential customers that such solution have some niche. First of all, yeah, I already answered about question when use of drone can be beneficial. How long the data cable can be? I don't understand the reason for that question. We use approximately 2.6 meters long cable, but in general, right question is how short can be that cable? Because shorter cable means less drag or difference between real sensor coordinate in the water and coordinate measurement by GPS receiver on the drone. So why we use 2.5 meter long cable? For two reasons. First reason is just psychological. It is much more comfortable for operator to see that drone is on reasonable altitude over water surface. Second reason is more practical. In case if you will use terrain following mode to do bathymetric survey, and drone will drag the sensor in the water, continuously drag the sensor, and if you predict the risks that it can be something like seaweeds in the water or abandoned nets or something, in case of altitude 2.5 meters, operator will have a couple of seconds to stop the flight in automatic mode, move the drone back and try to recover sensor from the water. For example, in case of oxidation ponds, you can use shorter cable to get more clean data, more precise data. But I don't see reasons to use longer cable. So, which drone can be used with a sensor? Currently, our system compatible with a range of DJI drones, but it is medium or big drones. It is M600, M600 Pro, M210 series, and support for M300 is coming. And also our system works with drones based on Pixhawk autopilot with Ardocopter firmware. This system is too heavy for small drones like Phantom or Inspire, and such drones doesn't have API port on the autopilot, so we cannot connect our onboard computer to the autopilot. Next question: how much reliable is it at high altitude? Could you clarify your question? I don't get it. Setup was already demonstrated, and you can check video on our site with bathymetric survey and to see the same setup in action. Yes. Next question is about bathymetry in common, so already answered. Can drone avoid high plains in wetland areas? It depends on the model of drone. In case of M600, big drone, like we use it for demonstration, it doesn't have obstacle sensors. So if it will be obstacle, drone will crash. In case of more modern M210 or M300 drones, they have obstacle detection sensors. If drone will detect obstacle, drone will stop and hover. So operator can will have a possibility to move the drone, for example, to the next survey line, or to fly over obstacle and resume survey. Also in very in conditions when when there is too much obstacles or distance between obstacles is too short, you can use altitude hold mode to fly manually between obstacles. So why altitude hold mode is important? More or less trained drone operator can control easily trajectory of the drone in horizontal plane, but if he will also have to control that sensor is in the water, workload can be too high. So it is why we are implementing altitude hold mode. Operator will have to put sensor to the water, activate altitude hold mode, and after that, he will have to use just right joystick of remote controller to fly in the survey area. And SkyHub will log the data automatically until sensor will be in the water. Next is what is the difference between echo sounder and propeller frequency? Echo sounder frequency is here on the screen. It is 450 kilohertz for single frequency and lower frequencies for dual frequency, but I don't get a question. We don't see any noise in data from propellers, from drone propellers, because because sensor is submerged to the water, and propellers are in the air, and there's absolutely no any noise from propellers in data. Why not use high frequency radar instead of echo sounder? If you mean ground penetrating radar, yes, you can use it. And on our site, you can see samples with ground penetrating radars. Each sensor has benefits. In case of bathymetry, why is better to use GPR? Just in two scenarios. It's our opinion, confirmed by experience of dozens of surveys using GPR. First, if water is covered by ice or partially covered by ice. So in such scenario, in such case, GPR is the only sensor which allows you to do bathymetry, not making a lot of holes in the ice to put echo sounder to the water. Second scenario, if current is so strong that you cannot use echo sounder on the rope on the drone, and you cannot use remotely operated boat, for example. In all other cases, echo sounder will deliver better results because it is sensors especially designed to do bathymetry, to measure depth of the in the water. It has much better precision, resolution, and data processing is trivial comparing to the data processing for the GPR. But again, there are two scenarios when low frequency GPR will be better. And also, of course, the same story as I described for why you can use drone with UAV drone with echo sounder. If you don't have both, so the same. If you have low frequency GPR and don't have echo sounder, you can try to use GPR, of course. Can we use software, Hydromagic for the GPR data as well? Answer is no, because technically it is the same format, seaweed, but from ground penetrating radar and from echo sounder, data will be encoded inside of seaweed files in different way. We can open seaweed files with echo sounder data in geophysical software, but Hydromagic cannot open GPR data. To process GPR data, if you want to do the same, I mean build 3D models, counter maps, I can recommend two brands of software. First is a GPR Slice, second is a web system called Geolytics. Next, can we use your echo sounder with our bot? Echo sounder is not we are not a sensor manufacturer. We use Echologger echo sounders, so you can use them with drone and you can use them on your bot. But our standard configuration is echo sounder with RS 232 interface, if you will order from us set for drone and will have intention to use it also on board, please specify that in order and we will supply you echo sounder with USB interface. And you will be able to use it together with our system and together with your bot. In such case, you will need to use, for example, laptop or tablet computer to log data from echo sounder. How to monitor gushing or fast rivers with high slope? Like some boulders and low riverbed, high altitude mountainous area. In such case, low frequency GPR can work better. I think, yeah, it's our second scenario when GPR can work better. Yeah. Have you tried to run small site scan sonar? We are doing to do that together with our partner, Turn Group. Turn Group, it's an interesting company. They're a consultant and reseller of many brands in bathymetric and all kinds of marine sensors manufacturers. So they already have small sites and sonar manufactured by Canadian company ImagineX. And they are integrating such that sonar, they are going to integrate that sonar with SkyHub. For SkyHub, we have public SDK, which allows quickly integrate different sensors together with all our infrastructure. I mean, data logging, geocoding, transmitting the data down to the ground, mission control, and everything which is necessary to do successful missions. So Turn Group integrated sound velocity probe to make sound speed profiles to more precisely process echo sounder data. Next step, they will integrate, as I remember, surface speed sensor, and third sensor in the queue is side scan sonar. When will be a GPR presentation? We already did GPR presentation. Please check webinar recordings.
Yes, here I'm showing in our news section, we have this webinar basic of GPR. So yes, here is the recording.
If you will not find enough information in recorded webinars, please write us questions. We will be happy to answer. How long is the flight time? And if I want to make a grid of 25 minutes for depth measurements, how much is the area can be covered during one flight? So flight time of M600 drone with echo sounder payload is approximately 15 minutes, 15 minutes. So for better understanding, I will return to HydroMagic.
You will share your screen?
Yep. I want to share my screen.
Yes, please do so.
Is HydroMagic visible?
Yes, it's connected.
Yes. So size of that lake or pond is approximately 180 meters per approximately 100 meters. So to survey that pond with, as I remember, 6 or 7 meters grid, we spent 3 flights of M600 drone. First, second, last one. And all survey took around, I don't remember exactly, around 1.5 hours. It is including all flights, changing batteries, everything. So if you need to survey really large areas, maybe it's better to use remotely operated boat. Of course, if you have it. So to answer on a question, how big area you can cover with some particular grid, it's better to plan the mission and see what UgCS will calculate for you. So you can drop us a message to ugcs@ugcs.com and we can plan some test missions together. Between EchoSounder and GPR, is there a significant price difference for the sensors? Yes, approximately 3 times. I mean, GPR, low frequency GPR are more expensive. And again, please use GPR, low frequency GPR for bathymetry if you have real reasons for that. Because EchoSounder data will be much more precise. I can illustrate difference as I remember for 125, 150 megahertz GPR system, resolution in the water will be around 30 centimeters. Resolution and precision. For EchoSounder, precision is 0.2% of the depth, and that means that for 10 meters deep water, precision will be 2 centimeters. But GPR can be used if you really need that. Okay, thank you so much for visiting us. I hope that presentation webinar was useful, and if you will have more questions, please, yes, send them to UgCS@ugcs.com.